Okay, cool. Hello everyone, and welcome to this talk. So today, my name is Tomás Vrancken, and indeed today I'm going to talk about how to self-host LLMs. So what if you don't want to indeed give your money to OpenAI, and if you want to host one of those, now pretty powerful open source LLMs that keep being released these days, and it's very booming. And so before I show that, and to do that, we're going to use VLLM, but I'll come to that in a moment. Beforehand, quick word about myself. So I work at ML6, in these offices. So we're a machine learning consulting company, which means we build ML applications for our customers that don't necessarily have the capacity for building ML applications themselves. We have different types of combination. We're industry agnostic, which means that we have a very wide range of possible projects. For example, right now I'm working on building a platform for generating legal documents with AI, of course. So if you're curious and if you snatch one of us for a chat, ask about our projects. We're doing pretty cool stuff. Next to L6, I'm actually wearing a second hat today. For the last couple of years, I had the opportunity of teaching a course of machine learning systems design at the University of Liège, where I'm from, in Belgium. So it's really a course of MLOps at the end of the day. So it's really the students, it's master's students in computer science and data science. So they really get a lot of the theory, what is really a transformer, etc. But they get a surprisingly low amount of concrete, more engineering skills on how to build applications around those machine learning models. So that's really what I try to bring in this course. Which I nicely open source. It's on GitHub, so this is really what I'm showing now, which I'll make a little bit bigger. So if you're curious, of course, you can check it out. It's at info1923-MLOps. Feel free to leave a star. And so all the material is in there. So again, if you're curious, you can check at the of course, I present all the material. It's actually very much ongoing. So next week I'm going to talk about monitoring and dashboarding. It's not yet up. I'm still working on those slides. Nevertheless, if you want to check, I also versioned last year's course, basically. So if you go on the tag, you can. The internet is a bit slow. That's not going to be an issue. But you can check last year's version. There we go. Which has all the material, but this year's is a bit better. So what I did recently with the students, is basically a demo on how to deploy, how to self-host LLM model on GKE, which is a Kubernetes hosted on Google Cloud, basically using GPUs. One thing that's pretty nice is Google is giving us educational credits, so the students get to have some money to spend on GPUs on Google Cloud, so they can do cool stuff like this. Now, I also thought maybe not everyone wants to start spending their money on Google Cloud, so for this session, I actually made another version of this demo, but how to host it locally. So I was chatting with someone earlier, hosting LLMs locally is you need to have a strong machine. So what I'm going to showcase is how to host a very lightweight LLM just for the purpose of how it works. And then whatever, if you have a very strong GPU at home, you can do it like that. I think hosting on the cloud is where it gets the most cost efficient. So that's probably the best place to use this. So without any further ado, I'll give a kind of shortcut through the repo, how it works. So as I was saying before, we use a VLLM here. So VLLM is an open source, it's an open source framework for hosting LLMs again. So it's pretty powerful. Basically, it does a lot of engineering behind the scene, a lot of optimization for hosting faster your LLMs, basically. So it has a couple of very powerful features. One of which, I won't go into the too nitty-gritty technical stuff, but is page attention, which is a more memory efficient way of storing the embeddings basically of your LLMs. So it's really the same LLM, but just with like smarter memory structure for the embeddings, which makes it just more memory efficient and faster. Likewise, go back to my page. So again, basically VLLM is going to make your LLM hosting. So by the way, it's working on top of Hugging Face, so you can just host any Hugging Face model, which you could do locally without VLLM, but VLLM again will, for example, use page attention, as I was saying, which can make it, which can reduce memory usage by 60%, so pretty powerful. It also has continuous batching, so if you're receiving a lot of requests to your LLM, it will batch them into very optimized batches, Because of course, if you're using GPUs and transformers are good for parallelization, basically. So yeah, smart batching can make your system much more efficient. Yeah, it's smart resource management. So it has, it works on top of CUDA. Yeah, precompiled common operations. Yeah, uses flash attention. It also integrates very well with quantization techniques. So quantization, in a tiny little nutshell, is all the weights of your model. When you hear parameters, if you hear llama has 7 billion parameters, those are all weights, which is numerical, right? Like it's just a number. And numbers can be stored in a float, let's say float 16, for example, which takes 16 bits to store one number. But you can also have int 8, which takes 8 bits, so it's half the memory size. So basically, you take all the weights of your system, you kind of round them up, it takes less memory, and it's faster. So it integrates very nicely. The API system is the same as OpenAI, which integrates well with most applications, basically. And you can use Python. So it will run models efficiently on your own hardware, save memory, it will scale nicely, etc. So if you want to try this at home, all you need is Python 3.8 or higher and at least 8 GB of RAM for the models I'm going to deploy, which my nice little MacBook has, so that should be fine. Okay, so I'll jump very quickly on, I'll jump to my terminal just to show how it works.
Can you make it a bit bigger?
Yeah. Yeah, I won't do too much coding, so don't worry. Actually, the purpose of this is also showing how easy it is. So the first thing you have to do is, in Python you have to create a virtual environment and install the required libraries. As I said before, it works on top of Hugging Face transformers, so you need to have that library, of course, installed. I already set up my environment, so that's fine. Okay, and then one of the fun part is to select which model you want to use. So I put some interesting options in here. So Facebook has optimized 125 million model, which is super lightweight, right? 125 million is a very small amount of parameter when you think of a llama 7 billion or DeepSeek that has like 600 plus billion parameters. So it's not a very, it's not the smartest model, but it's very good for this type of demo because it's super lightweight. You also have a tiny llama, only 1 billion parameter. You have your mid-range models that are going to require a bit more RAM, 16 GB, let's say. You have Qwen Pi2 from Microsoft. I know one of my colleagues is running Pi2 on his own machine, and now he uses Cursor, which is like GitHub Copilot, which is like a helper for writing codes, and he tries to make it work with his own deployed Pi2 because it's very nerdy like that. And then of course you have your larger model, but these are already testing the limit of hosting on your own machine, so I wouldn't necessarily advise going there. So there's a bit of like what kind of GPU or RAM you should expect for a different size of model. So. Okay, and then you basically want to deploy your model. So you can do that with Python, basically. It's very simple. It's a very simple library. You just have to select the model you want. Set some sampling parameters. You need the prompt, and then you can basically just run it. But what we want to do here is more showing how you can host a server. So again, super simple. At the end of the day, it's really just one single command where you call LLM basically, set the model you want to run, select the device type, etc., and some optimization, and of course where you want to port it. Which you see should run relatively fast. Again, if you use a larger model, then it will take a bit more time. Yeah, there we go. So the application is started. It started. I was a little bit afraid that the internet would drop on me, but it did not. And then you basically just can send a request. So here, for example, if we ask, maybe I'll do something different. So you have to write a prompt, of course. Any idea for a prompt that we can ask to our model?
Can you vibe code?
Can you vibe code? That's a good one.
Will be flight simulator.
Give it again.
Let's see. So it's not one of the instruct models, so it's like one of the old school models that really try to just do like text completion. So it's not really like a chatbot, if you see what I mean. Like it's really just going to try to complete this text. Let's see how it does that. Yeah. Okay, so this is the output really. Yeah. I gotta say, I almost find it funnier to interact with those very light models that go in every direction. So you can have fun. So preparing this, I also tried the mid-size model, and believe it or not, those actually crashed. So like this has been the most consistent model I tried. But yeah, now you have the direction for this thing. As you saw, it takes literally less than 2 minutes to set up. So if you want to experiment with different models, just try it at home, especially if you have a GPU. Last thing I'll mention is, as I was saying, this is the nice, funnier version for here. What I force my students to go through is more tedious, is doing this but on Kubernetes on Google Cloud. So you also have this version of the tutorial. Yeah, 90% of the effort is really going into deploying a Kubernetes cluster on Google Cloud and setting up a GPU node pool. But there again, like once you went through it, it's not too hard. There's a bit of like configuration that needs to go, especially in accessing GPUs. Basically, that's really like the hardest part, like the GPU to be available in the right location and everything. But yeah, it's based on a tutorial from Google, which I can show. Maybe first, yeah, there's like a whole Kubernetes deployment configuration to do. Actually, I was, so I did this 4 weeks ago, and 3 weeks ago Google decided to release Gemma 3. So this is using Gemma 2, which now feels so outdated, of course. So I was checking the tutorial again, and now of course it points to the version using Gemma 3, which I didn't have time to really like mess around with. But yeah, that would be a cool way to try it out. And actually, this is not where I want to go. And I think one of those tutorials also, if I find it, one of those tutorials also show how to do it on with DeepSeek. So if you really want to hit all the buzzwords and deploy your own DeepSeek on Google Cloud, it's theoretically possible. There again, also for Gemma 3, I don't know if I can show it super quick, but like Gemma 3, yeah, nice. They have a lot of nice release notes. This is probably very small for you guys to see, but yeah, they really compare it to DeepSeek and everything. Apparently, it's pretty strong performance. And apparently, this is what they're really trying to advertise. Again, very small, but they say DeepSeek requires, I don't know how many H100 GPUs, but a ton. But apparently, Gemma 3 only requires one. But I made all of this tutorial to work with the Belgian cluster to show the students they can also use data centers at home, which doesn't have NVIDIA H100. So again, I cannot go to the 27 billion, but you also have 147, I think, billion parameters, so you can do lighter weight Gemma models yourself. And then very last thing I'll conclude with is, why are we doing all of this when OpenAI lets you use GPT 4.5 for just 0.1 cent per token or whatever? So there's a lot of things to be said about open sourcing, not having vendor lock-in. Also like the immense power that those companies are really building and how it should belong to the community through open sourcing. Also, if you're building your own application for whatever reason, maybe you want it to be extra secure, depending on, for example, MSX, some of our customers are very sensitive, so they don't want their data to go to American company. So in terms of maybe safety or security or privacy, you want to not use one of those providers. But in reality, maintaining such an infrastructure for self-hosting models is a huge pain. It would require a lot of resources. So if you're going for self-hosting, really making it profitable would require a large usage, basically, to kind of like outweigh the infrastructure and management costs. So at ML6 again, we build a lot of AI application, and I still don't know of one where we're really doing our own self-hosting now. So food for thought. That's it for my talk.
All right, so questions. I think there was another microphone. What's around?
There is, but I'm not sure if it's configured.
I think the space is quite. Yeah, but it will get it better here. Let's see.
Yeah.
Perfect. Questions?
Hi, thanks for the talk. I'm just curious how this smart batching works with the LLM. If you can go into it a little bit.
Yeah, no, that's a good question. So I didn't research the exact technicity of how VLLM does it specifically. But there again, like if you, I don't know, if over a minute if you break it down into pretty small segments, I don't know, if over 3 seconds you're gonna get 1,000 requests, sending 10 and then 100 and then 500 requests is gonna jam the memory. So sometimes it's like waiting smartly to get a number of requests that parallelize very well over the GPU. Maybe the GPU has like X amount of tensors available, so 30 or whatever, and so maybe 32 requests is the optimal amount of usage of basically the GPU, and it's gonna pre-batch the requests to fill the GPU memory, so to say, and then send them by these batches to make it simple.
Smart queuing.
Yeah, exactly. It sounds very smart, but sometimes it's not so.
I think it's relatively good. So you use a batch in such a sense that you make full configuration.
Yeah, exactly. Yeah. Like that's also one thing they advertise on their platform a lot, or their GitHub repository. Is like really your GPU usage is going to be much more optimized.
Cool.
Question about the privacy while running the LLM globally. For example, let's suppose that we run DeepSeek, right? Questionable source, like very competent technically, but questionable sources. So, is there a way to monitor or limit the access that the model has while run locally to the little machine, but also in terms of network traffic, like some say unwarranted API calls that might be done to a server abroad?
Yeah. So you mean like to be sure that your data is not going to the people who made DeepSeek? Is that what you're saying?
Yes. So for example, like DeepSeek probably is the most blatant example of something that might be involved in that kind of scenario.
Yeah.
But it can really be anything, because even if you run something that is produced by OpenAI or Google or whatever, like it can still send some telemetry, in theory at least.
Yeah, exactly, and that's the point. So if you're using the commercial API from OpenAI, like you're sending your data basically to their data center or whatever they're doing. One note important there is, for example, if you use Azure OpenAI or I think Google Gemini, you can configure it to not store any of your data. So legally speaking, it's safe. But the point is, self-hosting is 100% secure. Like I'm really just downloading their model on my Kubernetes, on my server, and they have zero access to anything that's going into my server. So I have like full control. For example, if you're in a company that has their own server, like maybe like military grade type of company that has very, very secure infrastructure, I can set up my own Kubernetes, download the model, and no data will ever exit the system. Like it's 100% airtight. So that's like maximum security you can have essentially, and it's really through self-hosting of those models that you can guarantee that. Last note is just the models. If you download a Llama, so Facebook model or a DeepSeek model, you download it. It doesn't matter where it's coming from. The people who train the model don't have access to that.
No, okay, thank you.
Hey, thanks for the talk. It's not really a question, but more a remark. I think you mentioned the cost per request, right? But I think as an observation from commercially using open models, I see more of the use case in using open models that are hosted by someone else. And the main reason is spiky traffic. Because when you want to host for a certain capacity, you have to be very careful to handle spikes in certain situations, right? So for me, it would be more about concurrency, like how many tokens per second can you push out, how many users can you serve. And I think for most companies, it's probably going to be easier to pay a little bit more and have someone else host the open model instead of self-hosting it.
You can also.
You could auto scale, yeah. but it's very beefy machines that you have to
Yeah.
upscale. So.
Bindings, it will cost you a lot. Yeah, for it, if you can handle it.
Yeah, but I guess there are different models. So either you have your own infrastructure, in which case you need to have however amount of GPUs to manage the peak requests, right? So auto scaling will just optimize using the GPUs that you bought. But yeah, again, like you can also self-host on the cloud, right? So yeah, they can provision more GPU, and then you can have like smarter auto scaling indeed. But there again, like I think especially this graph was more meant to that.
Yeah, no, I know. It's just I think it's just an interesting discussion point too.
Yeah, for sure. I think that's where the industry also will evolve a lot. You know, NVIDIA is trying to produce a lot of GPUs, so yeah, maybe there's a future where it's much easier to do this ourselves. So.
Thanks.
I'm just curious how this compares with Olama, maybe other providers that are also offering something similar. We're evaluating a few right now, so just your thoughts.
That's a good question. I must say, Olama is not one I know. Yeah, so harder for me to. I would do what I usually do, which is just yeah. But there are other providers for doing this type of things. I think VLLM is really picking up speed. So yeah, yeah. I think you would have to compare to the specific one you want to compare to.
But honestly, I would think that like you would maybe be able to run VLLM and interface to it through Olama.
Isn't it using it as a backend?
That's what I'm
Is the backend.
Ah, okay.
Yeah. So Olama just basically gives you the backend. In fact, like for people who also want to try it out in a different way, there's also LM Studio, which also makes like a client where you can just download the model and create an REST API out of it, and that just runs locally as well. And Olama just gives you very similar kind of a backend to what you get with VLLM, but I don't know what exactly is the big difference between the two. You know?
Yeah, no, again, like harder to comment on Olama because I don't know too much about that one. But yeah, I know. I have to find it. It's also in one of my lectures. But there's a new framework from NVIDIA. Yeah, Dynamo, exactly. And I think Dynamo, I would have to double check. I might say something stupid, but I think it's also running on top of VLLM. So yeah, some of those frameworks are basically another layer of abstraction above VLLM, which again is really just like the optimization of the GPU to make it so.
So for those who kind of want to have a difference between Olama and VLLM, the main difference is that Olama uses as a backend Llama C++, and Olama is more focused on kind of local deployments, more smaller deployments, whereas VLLM is more focused towards larger deployments. VLLM, as far as I recall, is also more performant, and it supports more models, but it does require more work to work with.
Yeah.
So
More tokens per minute.
Just has a better developer experience.
Exactly.
It's very super easy to use, pick up, but that's what I was like quickly Google what was the difference between Olama and VLLM, and they actually said that bigger models VLLM is what's preferred.
On the docs also in VLLM on the GitHub, it says what recommendations are. So stands for TLM, SGLang. These are inference engines.
Yeah.
It's different between inference provider.
Yeah.
Yeah, exactly. Yeah.
What model are you using for CPU backend? Olama or
Olama.
yeah, Olama is just a wrapper that gives you an easy developer experience. They don't actually run the model itself. They use internally Llama C++.
I think they're stuck to use LLMs in relation to.
Yeah, they intend to just kind of be a one-click install, very easy experience.
And Linux already shows us local. You mostly use Olama for local. VLM is a different service.
It's also interesting in the LLM repo, there is a folder called AI Bricks, which is TikTok's whole AI structure, and what they use for surfing, which is based on VLM, but all the scaling up, down, everything is in there. It's quite complex, but very cool. So, if you're interested, would recommend. And if they use it at that scale, then it's production ready, I would say.
All right, last one.
So I'm curious about the Facebook model. I wanted to understand the context. Let's say if we asked what would happen if we mix blue and yellow, would it reply a logical answer, or I'm curious.
Yeah, like I don't know for that model specifically, but yeah, like all these models, they're vaguely similar. So if you're a GPT model,
Can we try?
oh, the one I deployed, yeah, if it's still up and running, sure. Okay, let's do it. I hope it's still running. Yeah. Okay. What was the question?
What happens if you mix blue and yellow?
Yeah, that's a question.
Colors.
And you have to give it credit, like the first question wasn't logical, so. Give it logical.
And maybe microcoding wasn't as
it's not a very powerful model, this one.
This is a real stochastic parrot.
Yeah, no, indeed. So yeah, it would be interesting to mess around with different models. So.
You could change the
Yeah, it starts. So the exact question was, what happens if you mix blue and yellow, and then the LLM has to continue. It says when the ambient temperature drops below 0, it becomes defective. Really not what we were expecting.
Yeah, zero.
Can you please add color to the question? Then it specifies that blue and yellow is color.
I'm not sure if it was
temperature.
yeah, no.
Like yellow paint even.
So the temperature is temperature 0.7.
Ah.
Leave the green, yellow, red, black.
But yeah, you also have to know.
Lower the temperature or like
We just want to see it.
make it 0, 1.
Yeah, 0. Literally 0. 0, yeah.
No, then it just doesn't produce anything. So I think you have to again maybe deploy a larger model and see around.
It's poetic. It's poetic.
Yeah, that's a nicer way to think about it.
I have a feeling if you say when you mix blue and yellow, you get the color golden, you might get something, maybe.
We spent like till 10 o'clock just to get something.
Yeah, this is proper tinkering. So, great. All right, thank you, Tomás. That was great. Thank you very much.